Okay, we can get started. Does everybody realize there are more interesting talks than this one, right? Okay. You just want to be here just to chill out. It's a very comfortable cinema. Okay, good morning. It's very nice to be back in Krakow. It's even nicer giving a talk when I'm not drunk. The last time I was here, I gave a talk drunk, which is weird. Don't do it. It's very unprofessional. It's crazy unprofessional. So it's nice to be back. My name's Paul Stack. I'm Stack72 on Twitter. And this is a talk called Designing a System for Chaos. Okay. I am an engineer at a company called Pulumi. Pulumi is like an infrastructure as code tool. It's very cool. If you want to learn more about it, come and find me. I'm a big infrastructure enthusiast, and I am a DevOps extremist. I love DevOps. I've been speaking about like things in the DevOps world for about 6 or 7 years now, and it's something I do every day on a day-to-day basis. Come in, join us. It's okay. So, has anyone heard the term distributed systems? Yeah? Do we have any distributed systems engineers in the room? 1. Do we have any full stack engineers in the room? Liar. You can't be a distributed system engineer and a full... I'm joking. Okay, so systems today have become a lot more complicated, okay, a lot more complex. We have moved beyond the era of having one large monolithic system, and we would deploy that same system 5 or 6 times, and that would be classed as like a load balanced system. And we have split everything up, okay? So microservices are the hotness at the minute, although people are actually starting to move away from microservices again because they're like too interesting for some people. But effectively, we have a system that is broken down into many parts, okay? This is a picture taken from App Dynamics, okay, which is like an APM, application monitoring tool. And it basically shows how all of the components of a system talk to each other. Now, this is a very small snapshot. Okay, but we can see that there's like web tier, e-commerce tier, customer tier, MongoDB, don't know why you'd ever use it, ActiveMQ, MySQL, you have lots of different things going on here. And it's a lot more moving parts than we are used to, okay? Can anybody realistically tell me, and I will offer, and this doesn't happen very often, I will offer to buy the person a beer. Okay, I'm Irish, I'm stingy. I will offer to buy the person a beer if they can realistically tell me that their development environment mimics that of production. Can anybody tell me that that is the case? One person. Oh, does that mean you get half a beer? Okay, we'll go for half a beer, okay? Now, when I mean does it mimic production, I mean does it mimic the same traffic? Does it mimic the same users? Does it mimic the same data? And realistically, the answer is no. Okay, because we have development machines, we have like workstations, and they're never designed to be the same as production. Okay, really never designed. So what actually happens is that we can't really test in a test or a development environment, so we start to test in production. Okay, if Chuck Norris says it's okay, then it's okay. Now, the trouble is that testing in production is very, it makes people nervous. It really makes your company nervous when you tell your CTO or your boss, listen, we're going to just push this to production and then we'll test it in production. And they'll be looking at you going, really? Really? You want to do that? But it's very, very difficult to do it otherwise. Now, we can test as much as we can test on our local machines, but ultimately, the best users of our system are our testers. The best testers of our system are our end users. They will find holes in your system that you never knew existed. Really. So how do we build a complex distributed system and scale it? Now, we're not very good at this. Nobody is really very good at this. And there's been a lot of problems in the past couple of years. The 737 MAX software problem. French customs. Any French people in here? They're on strike, of course. That's why they're not here. But like they delay everything. Like strike actions delay everything around the world. Okay, The bottom one is just amazing. An unsecured MongoDB exposes the Kremlin's backdoor into Russian businesses. I'm not even going to go there. We have customer payments going down, BA's global IT systems going down, Azure data was deleted because of a DNS outage. There's a great one that MySpace actually admitted a couple of months ago that they actually lost all of their music uploads between 2003 and 2015. That was because they put them all into a single S3 bucket, and the S3 bucket was destroyed. One single S3 bucket for 12 years worth of people's music. And then just like 2 days ago, there was a new one. A database, which was an Elasticsearch cluster, actually leaked about the 20 million people's data, including 6.7 million users, children. Now, we're not very good at this, okay? And recent events in the past few years have shown that the more that we try and make our systems complicated, the more difficult it's becoming in order to keep them secure and keep them online and not really have any outages. But then Netflix have actually specifically said the best way to avoid failure is to fail constantly. Okay? And that's a very interesting statement. So that doesn't mean that your site should be down all the time or your system should be down all the time. What it means is that you should never be afraid of failure because we fail on a day-to-day basis. You need to deal with it, learn from it, and move forward. And thus we introduce what's called chaos engineering. Anyone heard of chaos engineering? Yeah. Anyone practice chaos engineering? A couple of people. Is it just because of the way you write code, or yeah? Okay. So chaos engineering is it's a new thing where people are starting to practice it and learn about it, but it's been around for a long time. And what it is it's effectively creating experiments on your distributed system in order to understand your system's capabilities and limitations. Okay, so to rephrase that in a different way, you need to learn where your system breaks so you can fix it and stop it from breaking. And the only way that you can do that is by testing, like continually testing what's going on. And if you do that, you'll avoid these outages and these problems that we were looking at. So can I ask a question? Can anybody in here tell me that they haven't had a production bug this week? I'm going to ignore him. It's fine. Really? Okay, so 3 people, right? Do you have metrics of your system? Does your system tell you and alert you when a problem happens? Because if it does and you still have no bugs, I'm seriously impressed. And my company are hiring, so come and see me. But what usually happens is people are like, yeah, I have no bugs. And you're like, yes. So how do you know you have no bugs? And they're like, well, we don't really know, but no users have complained. So we are in the situation where we don't really have like a single pane of glass in our company, okay, so that we can see what's going on in production. We can't see our metrics in one place, our logs in one place. And there are very few companies out there who allow, they've invested in this tooling to see what's going on in production. And even those people will actually happily say, yeah, we have bugs. We have bugs on a day-to-day basis. And they'll be able to tell what bugs they have and patch them very fast. An application can be made up of many layers, okay, or a system can be made of many layers. So let's talk about like hardware layer, network, database, cache layer, application layers. Of course, if you're in the cloud, you don't have to worry about hardware because it's taken care of for you. If you're in the serverless world, then you probably don't have to care about anything apart from the application layer and hosted systems. But because we have layers, we can inject chaos into any of these layers, and we can actually work out what happens in our system. So let's think of what we can do here. You have I've lost you. I have a loud voice, it's okay. So you have hardware, okay? You can test what happens when your hardware fails to your system. If you have a computer, go and pull the plug out from the computer. Can you continually develop? No. So at that point, you have seen the limitation of your system is you need power to your system. Network layer. You need network outbound access, probably, in order to work what's going on in your system, and probably inbound access. So if you do the equivalent of an npm install, or a go get, or I don't even know what, NuGet search, or whatever it is in the .NET world these days, if you have no internet access, then your system won't work. Okay, your system won't be able to download the packages. Database, the same. Delete your database. Does your system still work? Cache layer, delete your cache. What happens? Does your response times go from 0.1 seconds to 10 seconds because the cache is warming up? Application layer, just stop, put like a firewall and stop people hitting your application, and what happens? You can very easily inject chaos into any of your systems. And because of that, we can start to see what goes on in our graph. If we go back and have a look at what is going on in our distributed systems set. So, for example, if I injected chaos between my application server and my database server, then the e-commerce service talking to the app.db MySQL at the bottom, you would actually be able to see that that was under problems, under duress, and you would be able to see how your system is reacting based on this. So by having these styles of tools, you can understand what's going on. Chaos engineering has 4 key things that allow you to do this. Okay? You need to define the steady state of your system. Once you have defined the steady state, you will be able to check to make sure that that steady state is not a one-off. It continues as normal, and this is what goes on within your system. Then you will introduce events that mimic real-world situations. And then lastly, you'll try and disprove your hypothesis of steady state. So let's make it easier to understand. Let's think of a real-life example. When an application server connects to a database, my application is online. Okay, that's our steady state. That's the hypothesis. Now, let's introduce a real-world event. There is a problem with our database. Okay, so what we'll do here is we're not going to delete the database because that's stupid. We'll introduce like a firewall or security group rule that stops our application server talking to our database. Okay, like very, very, very easy, very simple in order to do it. When that happens, we can check what goes on with our system. Should our system still be working? If the answer is yes, but the system is down, then you can take corrective action and you can start to code in a defensive way to stop it happening. So if we think of a 500 page that's served to an end user, okay, that's an incredibly frustrating event. So wouldn't it be nicer if we degraded our application gracefully and we actually gave a nice user message that says, the system is offline right now, please check back again later, rather than just giving them a hard error page. And we can start to continually test. So if we run the first test, it fails. We introduce the new code. We run the test again, it passes. And you can keep running these tests to make sure that your system doesn't regress to show that bad user error. Now, you cannot do this without monitoring. You really cannot. Monitoring is the cornerstone of chaos engineering. It's the only thing that underlines every single thing. And there are usually 4 types of monitoring. Okay? There's system availability. Is your system up or down? Okay? Do you get 400s? Do you get 500s? Do you get 200s? Do you get whatever? Okay? It's just the uptime or downtime of your system. Who measures the uptime and downtime of your system? A couple of people. Not many. System metrics. System metrics are... I'm going to be rude. System metrics are what old-style operations people used to monitor, okay? Like people who did things like Nagios and all these like simple monitoring tools. And they would basically give you metrics like CPU, memory, disk. And they would just tell you, this server is full, the CPU spiked on it, and it would just give you very useless information, really. Now, people extended that. People extended those monitoring tools that they could actually start to give meaningful information. So by getting an alert in the middle of the night that says Web 2 has 95% CPU is of no use whatsoever. but getting an alert that says Web 2 has spiked in CPU from 20% to 95% over the last 15 minutes. It's a much more meaningful metric. And it's something that you can realize that in the last 15 minutes, there's a problem. Now, you couple that with other metrics. So like your disk has filled up, your database server disk has filled up. But being able to understand that in the last 2 hours, it's gone from 5% to 95%, you realize that coupled with the CPU metrics that your system is maybe under attack. Maybe there's a problem and your system is spewing extra logs. Maybe your application server can't talk to your database. Maybe your database can't talk to the real. So it helps you understand what's going on in the world. But system availability and system metrics together is what we would usually have done in like traditional software development houses. Okay, our companies would usually do those two. More advanced companies start to introduce user metrics. Okay, so let's think of the number of customer calls. If you have an e-commerce site, the number of customer calls you get per hour, and you can see how that differs hour to hour. Now, of course, if you normally get 20 calls an hour, and you have all of a sudden 500 calls in an hour, you can probably start to understand that there's maybe something wrong in your system. If there's something wrong in your system, you can look at metrics from 2 and 1 in order to understand and sort of drive down what's going on. But the most advanced metrics systems actually gather service-specific metrics. Okay, so this is things like the number of user registrations, the number of let's think of Amazon. Okay, the number of new people signing up to your system, to Amazon, the number of people actually making a purchase on Amazon, the amount of people that go through and like add things to wish list or check out or use the card or send things to friends. Companies will actually understand how many actions are happening on a day-to-day basis. I used to work for a company in America, and we could tell per day, per month, per year, how many people were supposed to be on our website. Okay, and we understood the seasonality trends because big days for us were things like Thanksgiving in America, Mother's Day, Valentine's Day, New Year's. And we could understand based on the trends, because we had gathered so much data throughout the years, when we needed to scale up and scale down because it was able to go through massive spikes. And we could only do that by collecting these service-specific metrics. And of course, that allowed us that if we knew that it was supposed to be 500 users on our site at this point, or 500 reservations, or 500 registrations, and it wasn't that, then we could actually start to track, is there a bug in our system? Is there something wrong that is stopping our users from actually doing what they're supposed to be doing at this time? There's a great book on monitoring, okay? And it's by James Turnbull. It's called The Art of Monitoring. And it was written maybe 5 or 6 years ago now. But it's extremely relevant, and it will help you understand that monitoring is not just about system and service metrics. Okay, you must start to understand how your users and how your applications are actually being monitored themselves. So you should know, for example, that if your application is making database calls, that they should happen within 100 milliseconds. If that rises and spikes in a huge way, or if it's like a large amount of standard deviations above what it's supposed to be, then you should be able to get an alert based on that so you can react to what's going on. So by doing all of this, we can get back into chaos engineering. By actually understanding the metrics of your system, you can actually start to experiment on your system. Now, the term chaos engineering actually spawned out of Netflix. I'm sure everyone in here has heard of Netflix. Has anyone not heard of Netflix? Exactly, right? And even as end consumers, we've heard of metrics, but as software engineers and developers and operators and stuff like that, we're even start to understand that Netflix are a very high standard of what people are doing in the industry right now. So it's no surprise that new things come from them. And this was a blog post they wrote in 2014, okay, which introduced the term chaos engineering. But this wasn't their first foray into chaos engineering. They actually started doing it in 2008. Okay? And they called it just resilience testing. Okay? But in all good professions in software, what we did is we packaged something up and we renamed it, because that's what we're awesome at. SOA, renamed to microservices. Okay, Scrum, Agile, DevOps, they're all things that have been happening in the industry for a long time. It's just that we're very good at being able to understand new names for them. And out of Netflix came a lot of tooling. Okay, this is a set of tools called the Simian Army. And the Simian Army is what their DevOps team, I'm going to say, is actually most famous for. So we have something right at the front, okay, which is the monkey with the guns called Chaos Monkey. Okay, and Chaos Monkey was a tool designed to help them understand about their system in Amazon. So for those who don't know, Netflix ran a lot of their code and their systems in Amazon. Amazon is broken down into regions. Okay, so regions are actually geographic regional positions. So for example, you have like US West, US East, EU West, AP North, AP South, so on and so forth. Each region is broken down into what's called availability zones. And what you would actually do is you would load balance your system across the availability zones within the region, because that way you can withstand different outages. And what they did is they wanted to create a suite of tools that would allow them to test this. So Chaos Monkey was the first one. It was an instance level test, like specifically designed at application or web servers, application servers, database servers, whatever, just an instance in Amazon. Okay, Droplet in DigitalOcean, an instance in GCP, I think it's called a VM in Azure, like different clouds have different names for it. And what they did is they wrote a tool that would, and it was deployed into their system, and randomly it would destroy a VM. Just randomly. Nobody knew when it was going to happen, because it was written with rules around probabilities and timelines and stuff like that, and it would just pick an instance at random, destroy it, and they would still be able to check that everything was working as expected. Okay. Of course, they would have got alerted when something went down. Their system probably would have repaired itself, and so on and so forth. So that wasn't enough for them. Chaos Monkey wasn't enough. They created a tool then called Chaos Kong. Okay, we can see the bigger simian. I don't know what it's called. Kong, like gorilla maybe. And what they actually did is this was targeted at an availability zone level, okay? And they would actually be able to simulate at any time what happened if one of the availability zones within their system went down. And then the big one at the back was actually designed, what happens if all of a region went down? So let's say, for example, for Netflix Poland, they store Amazon running EU Central. I think EU Central's in Germany. Okay, that's the closest Amazon data center to here. What happens to the experience in Poland of Netflix if the entire of EU Central went down? And how quickly could they realistically get back online? So they were able to simulate what happened and actually simulate tests of failing over from one data center to the other, which is an extremely useful test to run. Who practices it? Uber, Dropbox, Google, Amazon, Microsoft. Everyone's starting to practice this type of stuff. These are just some of the bigger names. And some of them got into it for very interesting reasons. So like Uber did it because master logs in the replication to S3 were actually failing. And what it did is it actually brought down their primary database instance because their log server filled up and there was no space for database transactions. Dropbox did it because of an outage of master pair replication in databases, and it brought down the entire Dropbox site. Google and Amazon have been doing this forever. Like since the dawn of both companies. They just haven't publicly said to people, hey, look, we're doing this specific thing. But what they actually called it was like disaster recovery testing. This is what we normally know this as, disaster recovery. How quickly can we actually recover when there's a disaster in our system? If you look at any major outage in the past few years, okay, and I'm 110% sure, and I know you can't even be 110% sure, that Boeing are now starting to practice chaos engineering, okay? And all of these huge companies who have had security problems and stuff, they're practicing chaos engineering. They're all going to be starting to adopt this. Anyone in here practice it? Not many people. Because it's scary. System failure happens. We really, really have to understand that it does happen. And it's only a matter of time until you do have a system failure within your company. Okay? I wish it doesn't happen to any of you, but unfortunately it will happen to all of us at some point. We will have a problem and we will be working continually for 24 hours or whatever stupid in order to get things back online. I'm sure people have already done it. Now, like every good situation, there are tools that have appeared. Okay? And this is a tool called Chaos Toolkit. Okay? Chaos Toolkit is an open source product, and it will allow you to write tests, and it will continually run them for you. And let's show you an example. So, you would write your test as follows. Terminating the database master should not prevent our application from running. Okay, so that's our hypothesis. Okay, then we give it a description. Don't worry about the tags, it's not interesting. So what we say is we define our steady state and we say right now, when all of our systems are healthy, everything is working and everything is as expected. And you can see that the probe should always return a 200. Okay, and if we don't get a 200, that steady state is no longer steady state and we will get an error. What we will do then is we will inject a real world event. So what we're going to do is terminate our DB. Okay, terminate our database master. Of course, this is in Kubernetes. You can see that it's got a pod. So it's much easier to do than like a real life database. And when they terminate that, they run a test and make sure that the application is working application is either online or offline. And it will actually go off and it will check the application logs and it'll check the database logs and it'll actually run another probe and it'll check to see if it's at the steady state or not. Now how that looks in reality is this. So right now we're running the chaos experiment. We're validating everything's there, and we're actually saying the steady state is met, the application database is up and running, their system's running. Now we're going to terminate our master. After we terminate our master, we're going to fetch our application logs, and we're waiting to see if our application goes offline, and it'll run the test again. Okay, it waits for 20 seconds, and it'll run the test again, and it'll tell us, is our application up or is it down, and is there a problem based on it? And we can see, no, everything's alive and healthy, everything's working, our application's there, and it's there. So it'll continually run as many times as you want it because you can actually run it in like a CI style environment. There is another one. The other tool is called Gremlin. So it's very important to note that Chaos Toolkit is free. Okay, you can go and you can like play in GitHub. Gremlin is actually a tool that you have. There are free versions of it, but if you want like a lot of the features, you have to pay for them. And Gremlin allows you when you log in that you'll get, say, look, create a new attack, and you'll be able to start to see what's actually going on. So we can say, you know, what happens when there's an instant shutdown, and we can see that we executed against this machine, and we can see that we lost communication with the machine, and so on and so forth. So if I click like new attack, it'll say, do you want to run it against hosts or containers? And then depending on what's there, you can choose a Gremlin. I don't have any online right now. And it'll allow you to specifically attack CPU, network, disk, actually terminate the instance, so on and so forth. The same for a container. You'll be able to take a lot of things offline. So tooling in this area has become much richer than it used to be. And because of that, people are able to hook this into their CI pipeline. Oh, I thought I put that back online, sorry. So they're actually able to hook that into their CI pipeline, and they're actually continually able to test what's going on. So how can I get started? So there's a lot of very interesting ways you can get started. And when I started giving this talk last year, I got some inspiration from some people of how just by simply talking to them of how they could introduce this into their environment at work. Now, this was actually at a conference in Russia, and we had this in front of everyone. He was like, okay, you've just told me everything about it, but what can I do tomorrow in my work in order to understand what's going on in our system? I asked him very simply, what do developers need on a day-to-day basis? He said, the development environment. I said, okay. I said, what happens if your development environment goes down? He said, well, developers can't work. I said, okay, so let's start small. Does anybody need to SSH or remote desktop into your development database or your development machines? He said, yeah. I said, turn off SSH access. Simple script, just turn it off. He's like, really? And I said, once you turn it off, see how long it is until someone notices that it's switched off. And I said, email me. 2 weeks later, he emailed me. No one understood that SSH access to the machines that they were able to use or supposed to be using on a day-to-day basis had been switched off. And when they did notice, all hell broke loose. They were like, oh my God, is our system even alive? What do we do? And then he was just able to switch it back on. And everyone was like, oh my God, everything's okay again. And he actually explained to them what he had done. Then he emailed me back and he said, what can I do next? And I said, okay, next thing is instead of actually turning off SSH access, once a day, once a week, whatever, reboot the machine. He's like, what? I said, how long has your machine been alive for? He says, I don't think it's ever been rebooted. Because that's development environment. Why does it have to be rebooted, right? And he rebooted the machine, literally, and within 5 minutes, somebody had posted in their company Slack saying, hey, the development machine's gone down. So they were able to understand very quickly by making these small tests that they needed these critical systems to be alive. Now, of course, these are development systems. This wasn't a case of him chaos engineering his development environment. It was to show that there is value in running these styles of tests. Because if you don't run these style of tests, if you do run these style of tests, it's very difficult to sell this to your boss, your CTO, or whatever, that you can actually cause problems in production. Okay, you go and tell your CTO tomorrow, hey, I'm just going to reboot the database server in production. He's going to go, nah, yeah, you're going to find a new job if you do. You'd be surprised. People still try it. And of course, if they do that, there's big problems. So you can start really, really, really small. And if you do start small, you can start to show value very quickly. This is one of these areas that you can't do a big bang. You can't stop everyone in the company tomorrow and say, hey, we're going to spend the next 2 weeks writing chaos tests. You'll stop all productivity and you'll cause more problems than you actually will solve. So you start really small. It's the same as any transition. It's actually based off of exactly what the keynote said. Transitions are slow, okay? But then they can speed up as they gain momentum. And it's probably usually 1 or 2 people who'll start trying to introduce this into an environment. Not everyone will, because it's not everyone's area of care. Okay, there's a lot of people in the industry right now that don't really care outside their own little box. They actually, stick within what they have to do on a day-to-day basis, and they don't see what goes on in the rest of the environment or the system. So you start very, very, very small, and then from starting very small, you start to gain this value, and you start to gain additional insight. Once you gain additional insight, you can then start to see what's going on. Now, there's actually a website online, and it's called Katacoda. And Katacoda, it allows you to actually do interactive testing in an environment that's not your own. Okay, so if you have like a hack day or something at work, you can start to run these scenarios. And if I go in Katacoda and I search for chaos, we'll start to see a scenario where it's called fault injection. And we can click start the scenario, and it's creating an environment for you. So look, you're immediately starting to learn about chaos engineering from an online learning tool that's free. Okay, you just log into it with your GitHub account, and you're not breaking anything in production. So then it's going to say, the first thing we need to do is we need to set up an environment of microservices so that you would execute this script. Look, these are all the scripts right here of what it's going to do, and you would click the button, And it's Istio, so it'll like download the world and it'll try and like service mesh everything together and everything like that. But effectively, it takes a while in order to get everything working. Once you're happy, you continue, and it follows exactly what happens through all the different things. You can go and try this today. Not today, of course, you're at a conference. But you can go and try this the next time you have some free time at work. And it will allow you to see exactly what's going on and mimic a real-world scenario that you can actually learn from and understand. Sorry, I clicked the wrong button. So there are a number of resources that you can follow on this. Okay, Principles of Chaos is a great resource. It will tell you the raw basics of why it's there and actually the science behind it. The Chaos community is a very good Slack, and you should probably go and join it if you're going to run Chaos experiments, because if you do not have someone who you can talk to who has done this before, you could very quickly get yourself into some problems. So it's always nice to have a mentor in the area. And there's a really good GitHub site called Awesome Chaos Engineering, and it's community curated information. Okay. There's also books. And this is a new book, actually. It's called Learning Chaos Engineering. It's by a guy called Russ Miles. Russ Miles is actually the person who wrote the Chaos Toolkit. And it's a very good insight into much more in depth of what you would do and why you would do it, and being able to understand about the experiments. And like any good thing, there's actually a conference on it. And what's actually funny is the conference is today. It just so happens it's in San Francisco, of course, so we can't go. We can't really make it, but it starts in like 7 hours, and a lot of the talks are going to be streamed. And after the conference, they will all be online that you're available to watch. So it's a lot of companies giving real-world insights as to what's happening. Now, chaos engineering doesn't just stop at your systems. Okay. Unfortunately, we are in the era of very big competition for hiring within our companies and our environments, and developers are much more of an asset these days than they used to be, and it's an extremely competitive market. And there are companies, and I'm not going to name them because some people are actually trying to do this within their organization. There are companies trying to run chaos experiments within their culture. Okay, so I'm going to give you a great example. A great example of a company who do things really well, and you've probably seen tweets like this saying, I've just joined company X, and look, when I got to my desk, my laptop was there, my key card was there, I had a lot of swag, I had t-shirts, my monitors, everything was perfect for them when they got in. But we've also heard of companies who suck. I worked for many companies who suck. Don't go to my LinkedIn, I promise. But what I mean by sucking is like, when you join the company, it takes like 3 weeks to get your laptop. And when you get your laptop, you then need to wait a further week that you get access to the environment. And you then have to wait for network shares and software. And also it's like, companies don't even give you the tools that you need in order to do your job. Okay, so it's very, very difficult when you're in that environment that you'll be happy working in the company. Okay, so a chaos experiment here would be the steady state of our system will be that our employees are happy and they get the tools that they need. Okay, that's going to be continue. New employees will come in, they'll get exactly the same. We're going to hypothesize that when we stop them getting the tools that they need or the access levels they need, they will get angry. Stop them buying what they need. If you work at a company that gives you free lunch, stop the free lunch. Stop free coffee. I would kill somebody if they stopped coffee. And beer. I'm not even going to go to beer. But you start to be able to understand that chaos is everywhere around us. It's not just in our systems. It's not in our applications. Let's think of here. Let's think of the video and audio equipment for the conference. If this goes down, they can't record the talks. We are living in an environment now that this is starting to become what we need to understand. That it can fail anywhere. The lights could fail now. The mic could fail now. Everything can fail and probably has in the past. So we need to understand that failure will happen and we can rectify it based on that. Anybody have any questions? No? Everyone's sleeping because I can't see anyone because this light is in my eyes. We have some sleepers. We don't. I'm joking. It's not that bad. This is a much shorter talk today because I'm not able to give demos. The demo's usually like a 35, 40-minute demo, but it needed to be a much more introduction-based one. If anybody's interested, they can come and sit with me and we can run through like an actual real-life chaos experiment over the next couple hours. I'm going to be around all day. But I really hope you enjoy the rest of the conference. If you need to tweet me about anything, tweet me at Stack72. And or if you completely disagree with why you should do chaos engineering, because I love tweets like that. Question?
What would you say to a company that's decided that they want to do chaos engineering and are now setting up a separate cluster and environment to do chaos engineering?
So the question is, what would I say to a company that have decided to do chaos engineering but have set up a separate environment and cluster to do their chaos engineering? In theory, it's not correct because you're not testing in production, but they're actually doing it in a way that they're trying to sell value within the company. So I actually think it's fine to do that. In the strictest possible terms, it's not the best way of doing it. But if it's a way that you will actually be able to break through what's going on, then I think it's actually very fair. Because it's very difficult for companies to like just go and do this in production. Otherwise, people will panic and people will start to see when there's a problem, we're not very good at coping under stress as people. Okay, humans are not good at that. And when we get stressed, we lash out and we blame. So if you did it in production, you could cause serious problems within your organization. And if your organization is not mature enough to understand it, then it's very difficult to do it. So I would say it's fine to start with, really. But of course, at some point, they're going to need to migrate to do it in the real life environment. Or maybe what could happen is their real life environment could migrate to that new chaos tested environment and do it that way. So it's like almost like a staged rollover. Any other questions? Question?
What you said is very interesting, but it seems that the cost of doing such tests is more than the advantage. For example, eventually it will take down its EU server. Then all the users in EU probably will experience some problem. Right?
Wonderful question. Okay, the question is that sometimes it sounds like this the cost of doing this almost outweighs the benefit from doing it. Is that to paraphrase? Okay. So let's think of this, right? Netflix don't take down their server, right? I gave you the wrong impression that was the case. What they do is they will actually like mimic that EU Central has gone offline, and they will actually like roll over like disaster recovery across to like a data center that's already created, it's like spun up and it's there, and that you won't even notice it as a user. But what they're doing is they're testing to make sure that it happens, and it can happen. Okay? Now let's think of if you ran an e-commerce system. If you ran an e-commerce system and your system goes down, that actually will cost you money. Okay? It will actually cost you money. And if it costs you money and hits your company in the pocket, then you'll very quickly be able to sell them on chaos testing. Because I'm not suggesting that you do a huge upfront investment in this. I'm really not. Please don't take that away from what I'm saying here today. This needs to be a gradual progression into what you're doing. Okay, you need to learn and like build this in as you go. So like Andy here is doing a talk on feature toggles. Okay, you can actually potentially use feature toggles for chaos testing. Okay, because you could switch something off on your website very fast in a canary like situation where like you can drive 1% of your users through this new path of your system with the feature disabled, and you can start to test what is happening with your system. Are people still able to do what they're supposed to do on the system? If they are, then great. You've built resilience into your system that features, the feature that you've toggled on and off, don't stop people being able to do anything. Now, if you have disabled the feature and they can't do it, of course, you would ring fence that, and you would then invest a little time to say, that feature is critical, therefore it cannot be switched off. You see what I mean? So it's about learning and making gradual change in order to understand what you're doing. Not sitting for 3 weeks as a team actually like writing chaos tests, because that is like a cost that your company will not be able to buy into. Make more sense now? Any other questions? I really can't see. This is awesome. I feel like I'm on stage. Okay, cool. So I have like 5 minutes left. So we'll finish early. But thank you all so much for being here. I'll be around all day if you want to talk more about it, because I know sometimes people don't like to stand up and talk about their specific use case. But come and find me. I'll be hanging around. I might be sleeping because I had some beers last night. But please come and talk about it, because it's a very interesting area, and like we can very much target your specific use cases or your specific company, and you can actually use me as like a pairing buddy, you know, a rubber duck in order to do it. So enjoy the rest of the conference. Thank you so much.